This video is going to look at how to rationalise the denominator of a fraction. Now, often when we have fractions, it's an awful lot easier to deal with them when it's the numerator which is got the third in rather than the denominator. So we're going to look at methods of doing that. And these first two examples are going to look at the simplest method, which is if you've just got a single term at the bottom which contains the third. And we're going to multiply this fraction by that third over that third. So what we're really doing here is just multiplying it by 1, but we're multiplying it by 1 in such a way that we rationalise the denominator. So the numerator, 2 multiplied by root 7, will become 2 root 7, and the denominator, root 7 multiplied by root 7, well, root 7 times root 7 is going to be root 49, which is just 7. So you can either think of it as root 7 times root 7 is root of 7 times 7 is root 49 is 7, or that multiplying by itself is just doing the inverse of the square root in the first place. So question 2 here. Exactly the same process, so I'm going to multiply by root 5 over root 5. So the numerator here is going to become 3 root 10, as I'm doing root 2 times root 5, and the denominator here is going to be 5. And I'm just going to double check, root 10, can that be simplified at all? No, there are no square numbers apart from 1 that go into it. But it's always worth checking. Question 3 here. Now I can't simply multiply by root 3 over root 3 this time, because I have 2 terms in the denominator, and if I multiply it by root 3, well, this one will become rational, but this one will become irrational, so I've still got an irrational denominator. Now the way I get round this is by multiplying by 2 minus root 3 over 2 minus root 3. And this is utilising the difference of 2 squares when we multiply the denominators. So let's see what we get. Well, the numerator is going to be 2 minus root 3. And the denominator, well, I could use double brackets and I could expand it all out, or I could use the difference of 2 squares. So it's going to be 2 times 2, 4, subtract root 3 times root 3, which is 3. And then I can simplify this to just 2 minus root 3, as the denominator here, 4 minus 3, is just going to give me 1. And then let's look at this final example, so a similar approach again. So I'm going to use the 3 plus root 5 to multiply by, and again this is making use of the difference of 2 squares on the denominator. So at the top here, well, I'm just going to write this out in full because I don't want to have to expand it just yet. I'm just going to, perhaps I should have done this on the last example really, but I want to make it clear I know what's going on. Right, so I've only got a single fraction and I'm just going to simplify it now. So I'm going to expand the numerator line, so that will give me 6 root 3 and 2 root 15. And neither of those can be simplified any further because there's no square factors. And then the difference of 2 squares, I get 9 minus 5. Since I've done 3 squared, subtract root 5 squared. So that will simplify to 6 root 3 plus 2 root 15 all over 4. And then I've got 2 as a common factor, so I'm going to simplify that to 3 root 3 plus root 15 all over 2.